So, okay, so I'm kind of puzzled because what you have just described here with writing to a off-screen memory basically is just double buffering, right?
That's somewhat correct, but what we've really done is sort of enhanced or regularized the double buffering. So, for example, I didn't really talk about Direct3D in this either. In particular, Direct3D, has always had double buffering or end buffering built in. GDI doesn't have direct support in the sense that there's an API call that says double buffer me. Instead, you can create an off-screen DC, draw to that, and then blit the entire DC. And the problem with that is that's entirely local to the application, and the rest of the system doesn't really know what's happening. With the composition system, what we're trying to do is make it so that the back buffers actually technically it's really the front buffer of the swap chain for D3D is visible to the compositor, and the compositor can do its magic on it, and that it's all registered with the composition system. And that was fundamental changes that we made during Vista, was to make it possible to create these redirection surfaces through the different APIs. So we changed the runtimes for Direct3D, and we changed the runtime for GDI to go create these redirection surfaces and register them with the DWM.
Okay, so as a programmer today, should I still continue to do double buffering if I'm just writing a regular GDI app? Or
yeah, so this will get into some of the output changes discussion, but for Direct3D, you continue doing exactly what you did before. We made some more efficiency improvements there, so that we made it so that what we call flip mode works directly to the compositor. So the front buffer, the end of the flip chain for D3D is exactly connected to the compositor, and so it's very efficient. And what was happening in the Vista timeframe is we were again making an extra copy of the memory. And so we wanted to eliminate that. For GDI, we didn't get as far along as we wanted to, that you still need to create an extra memory DC if you're trying to reduce flicker. And a lot of this comes down to the fact that GDI never had any sort of first-class double buffering support built into it. We looked at trying to add that, but again, it's the kind of thing that it wouldn't automatically work for every application. It would be a new API, and the applications would have to opt into that. And we're still not sure that we want to continue to add complicated changes to GDI that where applications have to go change to take advantage of them, versus do some new things that we're working on, which I'll talk about, are the new APIs that we're adding for new ways of doing output.
Okay, cool. So what are the new APIs? There's Direct2D, right, and there's Direct Write.
Okay, so again, I'm going to do some erasing.
Erasing. Let's erase.
So what we'll talk about is the output half of the system, or the output 2/3 of the system, depending on your point of view. Thanks.
Are we the erase holder?
So again, like if I did this as a 500-foot view, there's this thing called DirectX that has been around since 1995 or so.
Yes.
And originally, when DirectX was started, it was oriented towards to game development, and that we were really trying to make the PC be a first-class gaming platform. And so we added APIs for making use of hardware acceleration. There was direct input. There was some offshoots like DirectShow for doing video playback, and for sort of mainstream 2D graphics that we continued to support GDI. We did GDI Plus, and then we also did investments in Uniscribe to do text. And over time, what we've tried to do is make DirectX and the hardware acceleration that was provided through that sort of low-level platform become the foundation for all of the graphics that we were doing. And so we added 2 new APIs during Win 7 to essentially replace the text support in GDI, so that's Direct Write, and the 2D output support in GDI, that's Direct2D. And so you can think of Direct2D as being analogous to Direct3D. So we can expand this box a little bit, and there's a bunch of boxes in here now. So there's D2D, there's DWrite, there's D3D, and in particular, I'm going to highlight D3D10. There's DXVA for video acceleration. There's DXGI is the graphics infrastructure. So this was, as part of Windows Vista, we were trying to do a cleaner job of separating swap chain and adapter management from the actual rendering operations. And so that functionality is now in DXGI. Now over here, we still have GDI and GDI Plus. And in GDI today, we also have things for configuring the screen that you can configure the multi-mon, set the display resolution, and long term we want to see that migrate into DXGI, and so we've got sort of the start of that there. So in virtually every single one of these areas, each one of these should have its own little box. We've either added the box as a complete new thing or made some improvements in the area, and so I can sort of quickly go through some of these other changes. So I think we'll end up having more Channel 9 talks on D2D and D-Write.
So this is new, and that's new, right?
Yeah, these are brand new. The boxes didn't exist before. These boxes existed before, but we've augmented them. So like one of the things that comes as part of this package is, again, we'd like D3D, DirectX in itself to be the foundation for all the graphics. So what we had done in Windows Vista was change things so that we had Direct3D 9 in XP, and it continues to work in Vista and everything else. But we did a brand new API where we tried to clean up and regularize things, including doing this split between DXGI and D3D 10. But we made it so that as part of this regularization, that it only worked on specific D3D 10 hardware. We also did, as part of the Windows 7 work, we wanted to broaden the reach of this style of API, so we changed Direct3D 10 so that it could work on 9 hardware. And a lot of the reason for doing this was, we want to make it so that applications can target the broadest range of hardware, but still have some reasonable set of capabilities. And in Windows Vista, the compositor DWM was written on top of Direct3D 9. We moved it to Direct3D 10, and this new 10on9 API, or this 10on9 subset, as part of Windows 7 work. And of course, D2D takes advantage of the Direct3D 10 APIs to do its internal implementation. And in addition, we also have software rasterizers for both Direct3D 10 and